All right, let's talk about the absolute bedrock of all modern networking, the OSI and TCP IP models. Seriously, if you're diving into IT, cybersecurity, or computer science, you've got to get your head around these two. They're not just helpful, they're the key to understanding how our entire digital world is connected.
So, what are these things, really? Well, you can think of them as the blueprints for the internet. I mean, literally, they are the fundamental rulebooks for how anything digital gets from point A to point B. Whether you're sending a quick email or streaming your favorite show, these models are what make it all possible. Okay, first up, let's tackle the OSI model. Now, the best way to think about this one is as the universal theory of networking. It's this beautiful conceptual framework that the ISO, that's the International Organization for Standardization, came up with. The thing is, it was never really meant to be built protocol for protocol. It was designed to be the perfect guide, the gold standard for how any network should work in an ideal world.
And then, on the other side of the coin, you've got the TCP IP model. Now, this isn't some abstract theory. This is the real deal. This is the one that was actually built. It was developed by DARPA, the U.S. Department of Defense, way back for the early internet. It's the practical, hands-on model that is literally powering the internet you're using right now.
So if there's one thing you take away, let it be this. The OSI model is the beautiful, theoretical blueprint. It teaches us the why. But TCP/IP, that's the practical, no-nonsense implementation that's out there in the real world actually getting the job done. It's the how. One is the textbook, the other is the engine.
Okay, so what makes the OSI model so famous, so foundational? It's all about its structure. It takes the incredibly complex mess of network communication and neatly breaks it all down into count them, seven distinct, manageable layers. Let's check them out. And here they are, in all their glory. The best way to picture this is like a super organized postal service. You start down at the bottom, layer 1, the physical layer. That's literally the roads and the mail trucks, the actual cables, the Wi-Fi signals. Then you work your way all the way up the stack to layer 7, the application layer, which is you sitting at your desk writing the letter in your web browser. And because each layer has one specific job, it's an absolutely brilliant tool for learning and for troubleshooting. Now, let's switch gears back to TCP IP. Remember how we said it was more practical? Well, this is where you really see it. Instead of 7 layers, it streamlines the whole process down to just 4. So you've got the application, transport, internet, and network access layers. Now, it's not like TCP IP just throws away the ideas from the OSI model. Not at all. What it does, very cleverly, is it combines some of those 7 distinct layers into bigger, more practical groups that make more sense for a working network.
And this right here, this mapping, is where you get that aha moment. Just look at this. The top 3 layers of the OSI model, application, presentation, and session, they all get squished into a single application layer in TCP IP. Why? Because they all basically deal with the user's data. And then look down at the bottom, the data link and physical layers, they get combined into the network access layer. It's all the same logic, the same jobs are getting done, it's just bundled up for real-world efficiency.
Okay, so we see they're structured differently. But what does that actually mean? This isn't just about a different number of layers. These differences get right to the heart of what each model is for and how we use them. And it really all boils down to where they came from. You see, the OSI model was built by a standards committee to be a generic, one-size-fits-all reference guide. It's strict. TCP IP, on the other hand, was built by defense researchers at DARPA with a single clear mission: build a network that works and can survive anything. That's why it's a practical protocol suite, not just a reference model.
And this is such an important point. TCP IP isn't just a bunch of ideas on a whiteboard. It is defined by the real-world protocols we use every single second of the day. You see HTTP? That's your web browser. SMTP? That's your email. And that IP address your computer has? That's the internet layer. You are literally using the TCP IP suite right now to watch this.
So this leads to the big question, right? Which one should you actually focus on? And the answer is, you absolutely need both. There's no way around it. You need to learn the OSI model to understand the why, the core theory, the fundamentals that help you troubleshoot any problem and pass your exams. But you have to learn the TCP IP model to understand the how real-world networking, cloud computing, and all the internet technologies you'll work with actually function.
At the end of the day, it's a mistake to think of these as competing models. They're not. They're two sides of the very same coin. Think of it like this. The OSI model gives you the clarity, that perfect theoretical map. And the TCP IP model, that gives you the reality, the gritty, practical tools that built the modern world. If you want to truly master the internet, you have to master both.